excited to be here. This is my fourth Vancouver B-Sides. It's also the fourth Vancouver B-Sides. My second time speaking at it. So before I start, I'm going to do an outline. So if you're like getting coffee or whatever and you're like, should I ditch this talk? You can find out. So I'm going to start by going over what is continuous integration. That's what my talk is focusing on. I'm going to go over some common misconfigurations of CI systems. Then from the kind of attacker side of things, I'm going to talk about the code execution you can get through a CI system. I'm going to talk about pivoting between slaves and masters within the CI system, and then finally backdooring all the builds. So quick intro to myself. I'm Wesley WINEBERG. I used to work for a Vancouver company called WorldTech. They eventually got acquired by GE. I then went to work for a San Francisco company called Synac, and then just in the last year moved south, hopped the wall, and went to work for Microsoft. So currently I'm a member of the Microsoft Azure Red team, and so my focus is definitely on the offensive side of security. But we work closely with the blue team and purple team and green team and whatever colors you got, because offenses is really just one piece of your equation to get your systems all secure. And this talk is just kind of my own independent research. No company is behind it or anything like that. Thought I'd tell like a fun story. When I was looking at my intro slide here, I was like, oh, WorldTech, so many good memories. So at one point we hired a sales engineer, and he was going along, things were going good, and he put together a slide for GE. Actually, they were going to become our customer. We're a customer, we're trying to sell more stuff, and he put like a slide of current customers, put GE up there, because he figured GE would see it and like it. But it turns out GE gets super mad when you put their logo up without asking them. And so then WorldTech's like, oh dude, you screwed up, we didn't tell you, but you can't put their logo on. And then they told him he could never speak to customers again. So that was a fun story. So here's some logos. But for real, don't like complain to GE about that. Okay, so to start with, I'm gonna go over build systems themselves as kind of a history before we actually go on to continuous integration systems. So this is just my unofficial history, how I see the world. So back in the day, you had a code repository and you had a build server. Maybe even had like a few different build servers if you had lots of products. And you would do more or less iterative builds. You'd get code checked in. The thing would build your code eventually after a few hours. And if you broke the build, people would be mad because builds took a really long time. And then after your build was all done and the system spat something out, you could do some testing of that and file a bunch of bugs for anything that you found and kind of iterate and keep going, doing your cool waterfall model because that's what you did. But kind of importantly, at the end of the whole build cycle, deployment would be done by someone else. You as a developer it'd be really strange if you were the one pushing code onto a server or packaging and releasing a product to a customer, any things like that. Developers kind of did development, and other teams did server management, deployment, that sort of thing. So then kind of going back a little bit further, but tying into my talk, the history of build systems from a hacking perspective really ties into compilers themselves. So back in the 70s, apparently they had electricity and compilers. And so some dudes that worked for the Navy came up with the theory basically that at some point you have to trust the start of your chain of your software. And so the start of your software chain really is the compiler itself. If you can't trust your compiler, then there's really nothing that you can trust, because even the compiler to some extent gets compiled by itself to create new versions. Later on then, in 1984, Ken Thompson from Bell Labs, I think, published what was a popular paper, and it's still kind of a popular paper to reference, called Reflections on Trusting Trust, and he basically kind of just detailed that concept a little bit further and put it in a paper, and people liked papers. And so the theory of these attacks really hasn't changed since 1974 or 84, depending which one you like to reference. You can still backdoor a compiler and have it backdoor everything it builds, and kind of ruin the chain of trust that way. But practically speaking, there hasn't been a lot of real-world attacks using this methodology. You've got way more email viruses and things like that, things crawling websites, than you do people trying to target compilers, just because it doesn't scale as easily necessarily. Moving on to modern day though, this all kind of starts to change. So in modern day, we've moved to the world of DevOps. Everyone's doing DevOps. If you're here and you're not doing DevOps, you're probably also not making software or things like that. So DevOps comes with a bunch of different components, in terms of build systems at least, or build system pieces. So you've got CI, which is continuous integration. You've got CD, which is continuous delivery, and kind of a variation on that is continuous deployment. So mostly depending whether or not you've got a system that produces a software application, or whether you've got something that's running on a server like a website or something like that. There's also been a lot of components around infrastructure automation, so that your infrastructure itself is part of your DevOps process and can get deployed by software instead of a human. And kind of to glue all that together, there's a lot more instrumentation for your code, a lot more monitoring. There's fun trends like A/B testing and things like that. So when I talked to a few people and I said, hey, I'm going to talk at B-Sides, it's on continuous integration systems. These were like developers or other people that know about these things. They said, oh, what's like a CI system? So I figured I'd put up some logos, because when I tell someone, well, you know, like Jenkins, it's a continuous integration system, they say, oh, like Jenkins, okay. So I just picked some of the popular ones, the ones that I recognize most. There's a bunch that aren't here, and probably a whole bunch of startups in San Francisco really sad they didn't make the slide. But anyways, so you kind of got three groups. You got continuous integration, and these often bleed over into continuous deployment, which often bleeds over into infrastructure automation. So a lot of these can be used in more than one category, but this is a general grouping. And kind of to illustrate this a little bit more, put it all in perspective, and I don't think you can actually see this. We got like projectors everywhere, but it's still hard to see. But basically, the top line is continuous integration. That's the start of your DevOps process. The next line is continuous delivery, and you'd use this if you've got a manual deployment approval process or if you're making software. Otherwise, the next line down is continuous deployment. And so at the bottom, it shows you start from source control, you do a build, move over to staging, and then finally production. And so I've got Clippy here to help us out, because there's going to be various levels of people in the audience. Some people are going to be like, Wes, I don't care, just give me some exploits. And other people are going to be like, Wes, what's an exploit? I'm just in management, why do I care? So I'm going to try and cover both, so you don't have to get too worried. But basically, the point for all of this so far is that if your company makes software or like deploys websites or even tries to secure companies that do that, they're going to be doing DevOps and they're going to be following a lot of this process. So moving over to an attacker's perspective, what do they think of when they see DevOps? This is what I think of, and I'm going to generalize that to this is what all attackers think of. So when you hear that people are doing DevOps, what I think is people love trends. People just like rush into trends and do it because everyone's doing it. They don't want to get left behind. And actually for DevOps, that's a good thing. If you're still doing waterfall deployment and you're ready to release the next version of your product in a couple of years, you're probably getting left in the dust. But that doesn't mean that you're doing it securely. Continuous integration, I think continuously compromised compilers, continuous delivery, software that you can't trust right from the beginning, and continuous deployment. This is the one that I'm probably like really excited about. Now instead of me trying to hack one server engineer and pivot through a few servers and then maybe hack the next engineer. It's all just automated through software, which leads to the next point, use this one cool trick to backdoor all the servers at once. So DevOps has allowed companies to move a lot faster, but it's given a lot of new cool opportunities for attackers. And so this really isn't like a talk about DevOps, but I have a really hard time like talking about DevOps and not making fun of it when it comes to security. So we'll just throw these in. This is basically an illustration for people that like illustrations more than words of how DevOps and security work together. And then we might have some more like management type people in here or more concrete focused ones. So I've got like a pyramid of kind of why DevOps is a challenge, like why this picture is. So here's our pyramid. At the bottom of our pyramid, we've got a source code that's full of vulnerabilities. And it's full of vulnerabilities because the developers got told, build a feature. They didn't get told, make sure this feature is unhackable. They got told, build a feature. That's their job, they did it, and it's full of vulns. But that's okay, because we'll test it. And we'll test it in production, because that's the most realistic system to test it in. And now that we've got this cool A/B testing methodology, we can just kind of stage the vulnerable code to maybe 1/10 of our viewers, and only they'll be vulnerable until we notice. On top of that, we got to put all these systems on the internet. So you want to be successful, you got to look at successful companies and what they're doing. So you take someone like Google, they don't have a network boundary, they just put everything on the internet. So if we need to be successful, we should probably put all our DevOps system right on the internet. And then finally, we're going to sprinkle some AWS keys or SSH keys or other secret key material. Kind of like when you go to Olive Garden and you get like cheese on your salad. You just like see how much they'll put on. That's what you do with the creds. So that's our DevOps pyramid of why it's hard to do DevOps securely. All right, so of that pyramid, we're targeting CI systems. And the reason I thought it'd make a good talk is they're kind of the start of the chain of trust. You can compromise a deployment system, but deployment system just deploys whatever the CI system builds. Your CI system typically involves a lot of test automation. It's usually running your unit tests and things like that for you. And in kind of more advanced systems, usually those do a whole kind of build in a staging environment, and there's often a lot of creds involved that get shared over to other environments. If the CI system is instead of deploying a website or something like that, it's building a software application. If there's any code signing, often the code signing cert will get loaded into the CI system. Sometimes too, the CI systems are actually used as the deployment system, so you get a 2-for-1 deal if you hack the CI system. And finally, kind of like all areas of DevOps, many of these systems haven't had very much security review of the specific software itself. So I've been looking at random CI systems, deployment systems, what have you, over the last few years. And every time I look at it, I find some new vulnerabilities, which kind of tells me that no one's really done a heavy security audit of any of these products. So the systems I chose, I needed to choose some systems for this talk. I didn't want to choose too many, but I wanted to get a kind of a sampling. So I went on Google and I came across the top 8 continuous integration tools. Looked like this. So that screamed like legitimate Gartner quality results. And so Jenkins and TeamCity were the top 2. After that was Travis CI, but that is kind of continuous integration as a service. You don't host it yourself. Didn't really match what I wanted. And then next one was Go CD, but that has continuous deployment in its name, and I wanted CI. So then Bamboo was 5th, so it made the list. And Jenkins is made by someone. TeamCity is made by JetBrains. Bamboo is made by Atlassian. Okay, so that is a pretty lengthy intro, but I think you need to understand what all these systems are and where they fit in to understand why compromising them is good. So the biggest issue with CI systems, and really like I could do this slide and kind of stop here and it would give you enough to go on to either compromise or spend a lot of time trying to fix your system. And it's the fact that they're continuously misconfigured. You generally don't even need any vulnerabilities in any of these 3 software packages to hack into one of these systems. They're always going to be misconfigured. And so I thought a little bit about why every time I come across one of these systems, it's misconfigured. And it kind of ties to what the continuous integration products have to be. So to be successful, they've got to be highly configurable and adaptable. When companies have development and build environments, there are always these systems that have evolved over time. They've got all kinds of things kludged together. The build works, but just barely. And so to tie that then into a CI product, the CI product has to be very extensible, has to be very flexible. It has to be able to match all kinds of crazy environments that companies have. The issue with that, or the challenge with that, is that complexity and security are 2 opposites. You can either have a system or a function or a communications protocol that is secure, or you can have one that's complex. As soon as it gets any level of complexity that's hard to understand, there starts to be mistakes made in the implementation, and even the design. Really, people stop to understand how it works, so it's very difficult to audit for security. As we'll go over soon, for many of these continuous integration systems, you're kind of at a disadvantage from day one. When you do a fresh install, a lot of the install default options actually pose either somewhat of a vulnerability or leave your system directly vulnerable. This is actually kind of a trend within like DevOps and all the new software packages. You've got MongoDB or whatever, Elasticsearch, and they all say, well, security is up to the user, the implementer. Out of the box, none of that's turned on. 5-10 years ago, that used to get you like a CVE, like, oh, install uses no password, just log in with SA, what could go wrong? But we're kind of swinging back that way, and so CI systems are no different. High level for this slide though, if you just wonder why does any of this matter, your company has a CI system, it's definitely going to be misconfigured. Let's hope it's not on the internet, so you need to like go and find out. Okay, so default configurations is what I'll go through first. So I installed each of these CI systems just a couple weeks ago, fresh install, and took a look at how does it give you its configuration. So Jenkins, which previously was Hudson, is almost a decade old. It's actually a tool that's been around for a really long time. And when it first started out, it wasn't designed to have really any security functionality. The design for it was you have a trusted network somewhere, ideally that's not even connected to the internet. You do your source code check-ins and your builds on this network, and if a developer can get to the network, then they're assumed trusted. Over the last few years, it's become more and more of a mainstream tool, and so people are starting to use it in all sorts of environments. So the Jenkins team has been adding security features, and actually in the last couple of years, they made a lot of security improvements, partly due to having a lot of security vulnerabilities reported to them. That said, if you have an install that you did maybe 4 years ago, chances are it's using some of those old default config options. So even if you've applied all the latest patches, your configuration itself might be the vulnerability. By default, the server listens on port 8080, which isn't too significant. It's also not going to be something super easy to search for just on the internet. Lots of stuff runs on that. A fresh install forces a user-defined password. Otherwise, it generates an admin password for you that's pretty strong. By default, user registration is disabled. But by default, the authentication scheme that it chooses is just that any user is full admin. So if you've done a fresh install and then just added 5 developers to this, all 5 developers are going to have full control of the system. When you do an install as well, there's 2 options you're given. One is no plugins, and the other recommended option is, hey, install a bunch of plugins. There's, when I did install 66 plugins that it recommends you're probably going to want. And I'm going to talk about plugins briefly in a bit. And then last thing to note is that it installs a build slave right onto the build master server in the default configuration. And this will be important as well later when we go over that side of things. But overall, if you just did a default install, didn't add any more users, the current configuration actually isn't too bad. It's kind of fun to look at the historical default config options that used to be there. So they used to have a checkbox that said, hey, enable security. And this meant enable any sort of authentication. And I'm pretty sure, if I remember right, this just used to be by default not checked. And then eventually they made this default that is checked. Another fun one is CSRF. The requirement for that on any request to the web interface. This just used to be something they didn't support, and then eventually they added it in as optional, and now it's a full default. And then the last one is agent to master control, which I'll talk about briefly later as well. But that used to never be there, and instead they just documented an agent has full control over the master. Moving on to TeamCity. So when you do a fresh install, the default server listens on port 8111. And when you do the install, you're forced to choose both a username for the admin user as well as a password. So it's kind of up to the installer how strong that is. A big issue with this system, though, is that user registration is enabled by default. And it's, I don't know if I'd say it's hidden in the configuration menu, but you got to go look for it to turn it off. Other interesting piece of this is that by default, all user accounts are put into the group project developer, which chains up the group levels, which I'll talk a bit more about later. By default, the build slaves use unidirectional communication, and by default, there's one build slave installed onto the master server. Next is Bamboo. This is the last of the three that I looked at. So a default install of this listens on port 8085. And I mention all these port numbers just because if you're on your network, you go looking for one of these ports, combine that with the page title of Bamboo or TeamCity or whatever, it can be a really great way to just find what might be a default install. With Bamboo, they're forced to choose both a username and password as well, just like TeamCity. And like TeamCity, user registration is also enabled by default. When you register a new user, they're put into the Bamboo user group. And that group really only has view access to the system, so it's pretty limited. But what is also really interesting is that by default, you don't even need to log in to get view permission. So unauthenticated users also inherit that view permission. I don't have a bullet here for that, but it's true. By default, there's only two groups, Bamboo admin. So similar to Jenkins, if you add 5 developers to your freshly installed Bamboo server, you're going to put them in the admin group so that they can actually do things, but that gives them full control of the server. Another interesting option that's checked is resolve artifact contents by extension. So this option gives you a hyperlink. You can go read the help, and it says this would lead to cross-site scripting attacks if someone checks in, say, a web page and then makes that a build artifact, but that's a default. And this one as well, a build slave installed onto the build master server. So I mentioned that you can go look on your own network for these ports, but what often happens, and there was some write-ups on this a couple of years ago, and people kind of started to go looking, is, remember stage 3 of our DevOps pyramid, you don't want to have boundaries anymore, you don't want to have this on your internal network, you want to have teams around the world all accessing your build server, which you've made online. So I went on Showdown and searched for port 8080 and the word Jenkins, and that came back with just under 20,000 hosts online. I then did like a few more searches to make sure they were Jenkins, and then I put that Jenkins needs to be in the title, because it always is, and that only ended up with 3,400 hosts online. I then did a bunch more queries, and basically Showdown's 100% flaky on how it does its searching algorithms. So anytime you see a presentation and people are referencing Shodan, the numbers are almost definitely wrong because Shodan does really weird things with its search. But that didn't stop me. I kept on going. Next was TeamCity. Shodan doesn't know about port 8111, or at least it claimed it didn't. But just searching on any port, I found 3,200 hosts. And then for Atlassian Bamboo, I found a grand total of 2. So I guess it's not very popular, or Shodan doesn't index it well, or maybe both. But all of these are not necessarily going to be defaults, but I was trying to pair it up with a port to go with the theory of if you're still running this on port 8080, maybe you're still using a lot of the other defaults. This leads to kind of a fun story, because I love fun stories. So you find yourself 14,000 Jenkins servers on Shodan. You think to yourself, wouldn't it be fun to see which one of these have user registrations enabled, build myself a new project, add a build command to send myself a shell, root the whole company, I'll be a great hacker. But just because you can doesn't mean that you should. So whoever in the audience, there's at least one person I'm sure who's like, I'm gonna pwn some Jenkins boxes right now. The story here is I was doing a pen test a couple years ago, privately contracted by some company. They wanted us to look at a number of things, including their external footprint. And I come across this Jenkins server, and then it was basically configured so that anyone could authenticate to it with their Google account. So it would redirect you to Google, you'd authenticate it to it, and then it would create you a user account basically. It wasn't whitelisting it, it was just looking for any account, drop you in the server. So I go ahead and do this, and as you can see there in yellow, I blocked it out, but that was my account I created, and thought, hey, cool, that's neat, it dropped me into the server. And then I saw there was only 6 other users on it, or 5 other users on it. So I took a quick look through them, and 3 of them were employees, and then I came across this other one, Nahumsec, and then I see the name, Ben whatever it is, and I'm like, hey, this name looks familiar, so I punched it in Google, and sure enough, this guy does bug bounty testing all the time, and I guess had just run a script of find all the Jenkins servers, log into as many as I can, or he was doing it by hand, I don't know, but he ended up making himself an account on the server. So I was like, oh, that's not cool. But then, like, I really like to think of things from the hacker perspective. And my perspective then would be, well, if this company didn't like that, they shouldn't have enabled anyone to just log in with Gmail. So good for him. But you gotta kind of like take one more step back and consider what's really gonna happen in reality. So what's really gonna happen is you're gonna go on Google, you're gonna find someone's Jenkins server, you're gonna log into it, it's gonna make you an account. I don't know why you'd use your real Gmail account, but he did. And then you're gonna look around and be like, wow, these guys are boned, this server's not configured right at all. And then you're gonna move on to hacking other things. And then 6 months is gonna go by, someone's gonna come along, and they're gonna ransomware this server. They're gonna bring in some top-notch auditors from whatever incident response company you like. They're gonna come in, they're gonna look in the user list, and they're gonna be like, Ben, let me use my threat intelligence feed Google to punch this name in. They're gonna come up with your name, they're gonna find your contact info, and you're gonna be trying to defend yourself from a lawsuit as to, oh no, I didn't ransomware the server, I just logged in and looked around and it was cool. So, bit of a tangent, but fun story. I find people in the wild hacking other companies that they probably shouldn't be. And if you're gonna do that, go through 6 proxies and use a different name. All right, so what are some common misconfigurations to look for? So say you've done a default install, but now you've let your developer operations team configure it a bit. So there's still a ton of stuff that is going to go wrong. I've just put together a list of the most common things I've seen here, but every system has its own set of issues, and all you really need to do is look through what can be configured, and every second item will probably be configured wrong. So the first is user registration. So some systems take the theory that we'll let anyone register, but they just have project viewing rights. on pretty much all of these systems, even a low permission user ends up being a disaster. So even if you can just view a project, you can often view the build logs, you can often view the build artifacts, and you can often view the test artifacts. And one of those almost always includes credentials for talking to the next system. The systems now, the CI systems now, at least the ones I looked at here, have various scripts that try and guess where a credential is in the output and mask it off for you, but it's mostly up to the user to configure that feature. So there's almost always creds that get through. There's also going to be a lot of good techniques that you can try with just viewing. I'll go over some more of them later. The next is anonymous access, and this kind of follows with the first one. A lot of companies take the approach of, well, developers can log in and trigger a build, but maybe their manager needs to see it, and maybe everyone in the company needs to kind of see the current status, so we'll make that open. And same issue. You start to be able to view artifacts and logs and other items. The next one I think is probably the most common is that developers don't just have access to trigger a build, they have full access over at least a project within the system. And so I'll talk a little bit later about how you go from having access to a project to having full control over the CI system, but the two are basically the same. If you have project admin access, that's just as good as full admin access, almost always. Kind of tying in with that, larger companies, even smaller companies really, often they have more than one project on the go. Maybe you've got a software application, maybe you've got a website that your software application uses, and you also have, say, your own corporate website, all getting built by your same CI system. Within your company, you've got different teams. People wouldn't have access to log into one server compared to the other, but you're all using the exact same build environment, using the exact same build slaves, and it makes it very possible to pivot from one person's project to another. The next thing, and this is kind of the second piece of what you do once you get access to one of these servers. Almost always the build systems have credentials with tons of access. So that might be SSH credentials to push the deployment out to a server that you've that's hosting your production or staging environment. It might be an SSH credential that just has access to every server because we don't know in advance what the build system's going to build for, so let's just cover our bases. There's often things like AWS keys if you're doing hosting in the cloud. Could be Azure management keys, could be whatever cloud provider you love. And then in more corporate environments, let's say startup and more bigger company, I often see Active Directory accounts so that the build system can talk to various internal corporate resources that it needs. These Active Directory accounts often have a lot of access, a lot more than a normal user. And then the last piece is plugins to these systems. So I think of CI systems like I think of WordPress. Like off the bat, WordPress isn't great. People find hacks in it all the time, but it's actually not terrible. I wouldn't necessarily expect to sit down right now, download the WordPress source code, and come up with a vuln in a couple hours. But the plugins for WordPress, they're a disaster, and I would expect to find a vuln in 2 hours. Same kind of thing with the CI systems. The plugins often haven't received as much review or as attention, but they let a company get something done. Maybe they just need to integrate to their Active Directory environment. So someone wrote together some LDAP connector, and it gets that job done, kind of. All right. So expanding on that previous scenario a little bit more, say you have read-only access. There's two great things that I'd always try. The first is list out the users on the system. Chances are there's going to be an account called test, or there's going to be an account called dev test, or there's going to be an account called build 1, build 2, build 3, and they probably have a super weak password. So you might not have known those usernames before, but since you have read access, you can list those out and potentially just take over those accounts directly. I've had a lot of success with this one. The next thing is, kind of going back to those plugins, a lot of the systems let you generate API or authentication keys to talk to other systems, and they often expose these to anyone with read access because you need to know what key to pass to your secondary system. So sometimes this is done through a plugin, sometimes it's built right in, but often you can do something like say, hey, show me the API key for talking to the CI's REST API. And so even though you only have read access, you've now got an API key with full access. So the Clippy notes on this is you need to tell your developers, hey, there's all these misconfigurations. Saw some guy at B-Sides, he says they're never configured right. But further to that, you need to get your developers to check regularly. CI systems don't generally start off super vulnerable, except those default configs, but they get more vulnerable over time. Every system generally does. The more you add to and change a system, the more opportunity there is for incorrect configurations. So monthly, every 2 months, every 6 months, I mean yearly if you have to, but regularly review your configuration because it's going to be changing over time and it doesn't matter that it was secure 3 years ago. Okay, so let's assume that we've got some sort of access to a CI system. Each CI system takes credentials and it feels like it needs to protect the credentials you gave it. So you gave it FTP server credentials or your SSH key or your AWS key or something. Now, I thought about this a bit, like big picture, why even protect these credentials? Because usually in these systems, if you have permission to read the stored credential, you've already got some level of admin access, which means you can probably just tell it to SSH to a server and run whatever command you want. You don't even need the key yourself. But on the other side, sometimes it's just a whole lot easier to collect all the credentials straight out of the credential file, take them offline, look through them, not leave any more traces or interactions on the CI server. For whatever reason, basically the threat model doesn't make a ton of sense to me, but everyone doesn't like credentials in plain text, I guess. So what does Jenkins do? So Jenkins used to, up until sometime in 2014-15, have a master key and have a secret key. I don't think it was actually per project. I think that was just like a thought at one point in time. And then they take a SHA-256 of one of them and they transform the other one a little bit, combine them together to get an AES decryption key for the secrets that are stored in the credentials.xml file. So someone made a quick Python script to decrypt that. You can also just use the script console within Jenkins to ask Jenkins itself to decrypt it for you, which is super handy once you have admin access to Jenkins. I wanted to double check that this all still worked, and I took a look at it, and they've definitely changed some parts of this. So I'm still figuring out a Python script to do new decryptions, but I'll get that sorted out and I'll post one of those pretty soon because it doesn't look like anyone's bothered to reverse engineer the new format. But Jenkins still does helpfully take all the credentials that you load into it and store them into one file. So once you get file system access, you can just grab that. For TeamCity, TeamCity treats credentials in two different ways, depending whether it's a string that you've entered or a file that you've uploaded. So if you've uploaded an SSH key or something like that as a file, it doesn't do any sort of encryption for that. I don't know that that's necessarily a vulnerability, but it makes it super easy to, just through their web interface, if you have project admin access, to click export a backup of this project, open up the zip file, and you're going to have the unencrypted SSH keys right there. Credential strings, though, are actually encrypted, and so what they do is they use triple DES. I'm told is not as broken as regular DES, but that doesn't really make sense, but I don't do crypto. Like real crypto, I just break it. Anyways, and then that's base 64 encoded. So if you look in your config files, you'll see all these base 64 encoded strings. They've got a little header on them to kind of flag that they're an encrypted base 64 string. So I took a look through their software. All of these systems are written in Java for some reason, Jenkins, TeamCity, and Bamboo, which makes it easy to reverse engineer because they didn't obfuscate it at all. And so I came up with the decryption key here, and I made a Python script to do the decryption. I told TeamCity about this a couple of years ago. Said, hey, you know, you've just hard-coded a encryption key in your application. Is that good. And they said that they thought it was not a problem necessarily because you need admin access to get these files in the first place. So I don't necessarily disagree with that, but I asked them, like, so is it cool if I post this key? And they said yes. So here we are, a couple years later, got around to it. Bamboo takes credentials and it stores them in its database. Doesn't store them on the file system necessarily, although the database might be on the file system depending how you've configured it. It takes a similar approach as TeamCity. It has, well, it's kind of like a bit of TeamCity and a bit of Jenkins. It AES encrypts your keys, and it uses a key file on disk that I've got listed out there, cipher.key_0, and then it uses a key that's in its database. It XORs those two keys together, takes the IV from the database, and then can decrypt the secret. So I've got a script for that at the end of my presentation as well. Moving on, so you've got all the credentials, that's great. Kind of backing up a bit, maybe you don't have full access into these systems. How are they possibly configured? How might you be able to change that? So Jenkins has 6 different authorization schemes you can use because these kind of like follow from its legacy history. So it has something called anyone can do anything, which I just call no authentication. It has legacy mode, which if you turn it on gives you a whole bunch of additional options, but I assume none of them are good. It has anonymous users have read access. So this means that you can have people who log in and have more access, but if you don't log in, you can still read everything. It has logged in users can do everything. This is the default. And then it has 2 options, matrix-based security and project-based security. And so both of those, if you look at the very bottom of the slide, if you kind of squint your eyes, you can see there's like a bajillion checkboxes. It makes it so you can have super granular permission either per project or just to all of Jenkins in terms of what a user can do. And it's everything from like view build results to, let's see here, run scripts, upload plugins, and so on. So chances are when someone's setting this up, they're just going to keep checking boxes until the system works as they were hoping, then they're going to stop. So that might mean that you want to try and get that view access, see what users have what permissions, and if you find someone with, say, upload plugins checked, then you're golden. The other thing to look for is Jenkins is used pretty heavily with custom authentication providers. So instead of using one of those 6, you can tie it to OAuth or OpenID or whatever. The challenge with tying it to those is they often don't work with your matrix-based security. So it's an all or nothing. Once you log in as one of those, then you just become admin. TeamCity has, I think, probably actually the easiest to understand permission model. They've got 4 default levels or groups, viewer, project viewer, developer, or project admin, and then a system admin category with control over everything. The one kind of trick or thing that I think people miss, or is easy to miss with TeamCity, is that your permissions groups can nest. So there's a global set of permission groups that every project inherits, and then per project permissions. So by default, everyone's put into the project developer group. So even if you then add a user later, pick a project, add them as a viewer, they'll still have developer permission to that group. And the second kind of piece of all of this is each of these groups can then be expanded into a more granular set of permissions. So kind of like the Jenkins list of options at the bottom, if a company has attempted to customize this a bit, they might have run into the same situation where they've given a little bit more permissions than is necessary. But even a project developer, which is kind of the most basic permission you can give your developer, they can view a project or start a build. When they start a build, they can supply parameters to that build. One of the parameters they can supply, well, not one of, but a set of the parameters they can supply is any of the environment variables that the build slave is going to use. So they can supply a new path variable, for example, and if they are otherwise able to log into that server, they can just rewrite what something like GCC gets pointed to and take over the permissions of the build slave. If you have project admin, that basically is going to give you remote code execution on the slaves. And like I mentioned earlier, you can get the project credentials super easy straight through the web interface by just requesting a project backup. So you don't necessarily need to compromise the whole build master. You can just take over that whole project. And last is Bamboo. This one really didn't have very much of a built-in permission system. It looks like it's two defaults, which is user that can only view, can't actually do anything, or admin that has full control. So I imagine that the idea is that you would then set up which permission level you actually want. And so there's only 4 that you can choose from. Access to view stuff, create a new plan, which is a project, create a repository, which is a source code repository, or admin. So really, the create plan or admin groups are going to be the 2 that let you actually get code running on the build slaves. But by default, everyone's just going to get made an admin in that system. So what's the high-level thought for all of these system permissions? High-level thought is it's going to take a lot of tuning with any of these to make sure that you've made the system usable for your developers so that when they check in code, they can run a one-off build or things like that. But it's going to be pretty difficult to prevent that developer from more or less having effective admin permission, because if they can run custom code on a build slave, as we'll talk about next, chances are they can take over the master server as well. So a solution that you might want to look at is maybe your developers don't generally need access to the CI system. Maybe you've got a few build engineers or an engineering manager that has access to the system. Depends on your company. Or the second is that you probably at least want to segment your CI systems. So instead of adding every new project to the same system, if you've got 2 teams that work on different projects that shouldn't trust each other, put those on 2 different sets of CI servers. I got a quick note here. Starting to run out of time. So basically, as a quick example, Jenkins had a bunch of plugins. I looked at one of them. I came across a server a customer was using. Used the Google authentication like I was mentioning before, but it was tied to their company's domain. I looked at the source code for the plugin, looked at what was happening behind the scenes, and basically the plugin developer had misunderstood how the OAuth flow worked with Google. So you could intercept the login that was taking place, and instead of telling it to authenticate to the customer's domain, you could pick any domain you want. Google would say, yeah, Wes owns, testdomain.com. Sure, he's authenticated to that. I'll tell the server, yeah, Wes is authenticated. The server assumes that I authenticated to their domain, not my own, and then lets me in. So this kind of vulnerability is pretty typical, I think, for plugins to any of these systems, not just Jenkins. So it's always worth considering the plugins. This next slide, I think, goes without saying, but it's worth highlighting. So the point of CI systems is to let administrators, product administrators, configure the source code repository, the build steps, and then kick off a build. That basically means the point of these systems is to allow tasks to run a command. So in Jenkins, you had a build step called the execute shell, and it lets you configure what shell command to run. TeamCity and Bamboo, same kind of thing. If you want a remote shell, all you do is tell it, run bash, tell bash to pipe me back a remote connection to my IP and port, and redirect input. So now you've got a remote bash shell. If it's a Windows build slave, I recommend some PowerShell magic, but same idea. So now you've got code running on your build slave. What if you want to take over the whole system? I'm calling it build slave here. Each system calls it something different, node or agent or what have you. I'm calling it slave because that's fine for computers, I think. Probably not for people. So if you can trigger a custom build, you can get code execution. And if nothing else, say you can't pivot back, anything else that gets built on that slave, you can now compromise or mess with. So that might be good enough depending on how they've architected where builds go to what slaves. In all the default configurations, you end up with a build slave running on the build master, and in the default configuration, that's running as the same user as the build master. So if a company has left this configuration in place, you can simply run code on the slave that's on the master and take over the master. If it's segmented, you're still going to need some paths back. So I don't have a lot of notes on these, but in Jenkins, there's a bunch of different protocols, 4 different protocols and 2 command line protocols to talk from the slave to the master. For old versions, there was no control over that, and so they just documented a slave can basically use Java remoting to call and tell the Jenkins master to execute whatever code you want. On new ones, they try and do function whitelisting, and I'm looking into this but haven't really finished looking into it. The theory, at least, is that slaves should really only be able to do limited things, upload job results and that type of thing. For TeamCity, I actually found a number of remote code execution vulnerabilities and how they did the slaves to master. So I still need to tell them about it, I guess, and disclose that in some way. But in the meantime, you kind of got 2 models for your slaves, either unidirectional or bidirectional. And they use a different protocol for each, so how you might want to attack those is going to vary. The XML one, I tried like a external entities attack, and that didn't work, so you don't have to try that, but other opportunities might exist. Authentication is actually pretty neat with TeamCity. TeamCity, a slave just picks its name and tells the master, hey, I'm a new slave. Do you want to authorize me? And there's a big list of new slaves. So if you want to just cause grief, you can like script up 1 million new slaves and they'll all show up in the list. Excuse me. The admin does still have to approve them, but you can mess with their system. Slaves are supposed to be pretty limited as to what they can access on master. So when things are working by design, they can really only upload job results. TeamCity doesn't use encryption by default for those links. It says just put it in a secure environment. Bamboo uses the bandana program, and the more slaves you have, the more you have to pay for them. So by default, chances are good the build slave is on the build master. I still haven't really looked into the protocol and auth, but I'll be like that guy pretty soon, hacking the Bamboo. So to kind of round things off, that's now that we've taken over the build master and build slave, how do we do a backdoor? The obvious way is just add a new build step. People probably aren't going to notice that something new is in there. Give it an innocent name like static security analysis. As Clippy says, say you're a developer and you notice this, do you even tell anyone? I probably wouldn't. A better way though is add a new plugin. There's 1 million plugins and no one knows what's going on and they have full control over the system. Plugins can be triggered at any point in the build process, and in most of the systems you can set it so the plugin runs against every project with no new changes to that project. So I'm going to post some examples of these at the end. But backdooring just a few jobs is good. Why not backdoor the whole system? I think the best offensive is plausible deniability. So you already know there's 1 million ways to do your configuration wrong. Once you've taken over one of these servers, just make the configuration less secure. Turn off CSRF protection, add some test accounts, maybe add a new auth provider, generate a whole bunch of API tokens. The possibilities are kind of endless, and most of these no one would ever know for sure was an attacker. But I kind of wanted to have time to talk about like the next level compromise scenario. So, excuse me. A backdoored compiler will backdoor all new versions of the compiler. A backdoored CI system can do the same. So you've got your CI server, you've got some build slaves. When you upgrade your CI server, it pushes new updates out to the build slaves as well. So say we took our scenario, we compromised a project, got our code running on a build slave, we've got a compromised build slave. I've got some animation here. It's pretty great. So we've got our build slave. It's infected, and now they realize someone's been messing with our system. We better reinstall the CI server. So they reinstall the CI server. It's all good. But your build slave is anticipating this, and since slaves have some level of permission back to the master, slave checks, is master still compromised? No. So it goes and rehacks the master, and then tells the master, yo, rehack all the other build slaves, and then this cycle just continues forever. Your changes are never pushed down to your build slaves fast enough for them to not rehack the CI server. So I haven't implemented this yet, but I totally want to, so be on the lookout. I'll post some code. So in summary, I think it's probably impossible to fully secure one of these systems. It's also probably impossible to clean up once someone's hacked these, just because the configurations are so complex. So that means don't put your systems on the internet, and if you do, at least put like an external authentication proxy in front of them. Don't just rely on the CI system's authentication. And you kind of should consider how much do you trust the output of one of these systems. Would you even know if it was backdooring your code? I kind of ran through a lot of points on this talk. There was another great talk given at Black Hat in the EU a couple years ago. So if you want to learn more about it, I definitely recommend this talk. I had expected that a bunch of the findings in that talk would have changed in the last couple of years, but I went back and read through it after I put together a bunch of my findings, and pretty much everything's still the exact same. So it's a little bit sad that not much has changed, but a lot of good reference in that talk. And otherwise, I'm going to post these slides and all the tools I referenced on my website probably in a day or two, which is there. And if you have any questions, you can find me here, or that's my email. And I don't know, we might have time for questions right now. I'm going to go with yes. Any questions?
Just a quick question. Your thoughts about in-house versus SaaS CI/CD systems, and you know, the threat surface and management of security controls.
Yeah. So the question was thoughts on SaaS versus in-house run. I didn't really look at SaaS systems. I would imagine it's kind of like any cloud-hosted system. Security overall is probably going to be a bit better, but one vulnerability is going to affect a ton of customers. But didn't really research that side of it. I know the in-house ones pretty much all vulnerable to the things I described. We got some more questions?
Hi. So some projects these days tend to go towards what's called reproducible builds, as in anyone can compile it and arrive at a file that's like hashable to the same hash, just to make sure it hasn't been tampered anywhere in the chain. How well do you think things like that might mitigate having a compromised CI system?
Yeah, so I think that's going to depend where and which CI system you compromise. So that's like a great theory to have in place, and probably something companies should try for. The challenge is, how do they generate the very first hash? So if you compromise the system that's generating the first hash, people's hashes aren't going to match after that, and then there's going to be a lot of confusion and anger and upsetment. So I think it kind of depends what you're trying to protect against, but with the theory of, say, you and I both check out the same project and should be able to come to the same build, that's actually going to be something that's a really good mitigation. CI system normally can talk to the source code repository, so there's also that challenge, which is maybe the CI system's not just tacking on a backdoor, but maybe it's specifically changing some of the source code right in the source code. That might be another angle. But no, I think that kind of thing sounds like definitely a good idea.
So my question is, it really seems that security is barely an afterthought with a lot of these systems. So how would you recommend, aside from kind of from an external security perspective, that these vendors take responsibility for the integration of security into these tools? Because it seems to me like that's the best place for that to happen.
Yeah, it's a bit of a challenge. Like I said, these tools really have to be adaptable to very complex environments, and that means by definition they're going to be very hard to fully secure and harden. I think the more a vendor is held accountable, the better they're going to get. I think Jenkins is probably a great example of that. 2 years ago, they were a complete disaster, in my opinion at least, in terms of security. And they started getting a lot of press and a lot of people complaining, for lack of a better word, that their security had issues. And so they then started actively looking at improving that. I think it's going to be basically up to customers to demand the changes before the vendors are going to put them in place. But I definitely agree, the vendors are really the ones best suited to fix the security challenges. All right, any questions?
Well, thank you. Thank you. Oh, I do have a mic.
There
All
we
right, thank
go.
you very much, Wes,
All right.
for that great talk. Let's give him a round of applause.